What you typically want to do with an organolithium or a Grignard reagent is use it as a nucleophile towards a carbonyl compound so that in the end you result in an alcohol. What you're typically going to start out with in these types of reactions will be a ketone or an aldehyde. You can do this kind of chemistry with carboxylic acids and esters as well. So there are 4 different types of compounds that you can do this chemistry with. But be aware, you're most commonly going to be doing this with aldehydes and ketones. So I'm going to give you a very simple ketone. And what you would see next to it would be the following. Typically, you would have a Grignard reagent. And this may be drawn for you in several different ways. You may first off see it like this. Now, MgBr could be a lithium if you're using the organolithium reagent. And the conditions here would be in diethyl ether, since that's how you make the organolithium and the Grignard reagents. They have to be stored in the solvent. You have to use them directly. And then after the fact, you would add acid. You cannot add an acid source early. If you do that, you will protonate the Grignard reagent. So this really does have to be a 1-2 type of a reaction. So let's look at how this occurs. So you have a ketone or an aldehyde, most often. You can do this with a carboxylic acid or an ester. And you have your Grignard reagent or your organolithium reagent. And I like drawing mine this way as ions, since that helps me see what I'm doing a little better. I know your book doesn't do this, it draws it as one complete complex, like I'm showing here. But I find that if you draw it this way, it will be easier for you. Anyway, what happens here is you have a nucleophile, which is your carbanion, and it will react with the carbonyl carbon. Now the way I know this is due to oxidation numbers. The carbonyl carbon is slightly positive due to the fact that there is resonance stabilization of the ketone or aldehyde or ester or carboxylic acid. You can break that pi bond between the carbon and the oxygen would get the electrons, and the carbon does bear a partial positive charge. So what we can do here is we can have the nucleophile attack this carbon, and as that happens you can't have 5 bonds, so the pi bond breaks, and you give the electrons to the oxygen. This will result, I'm going to draw out that carbon now, in a new base. And it will still be paired up with the magnesium and the bromide, or lithium if you're using the organolithium reagent. Now this is very favorable acid-base chemistry because initially you were starting out with a carbanion. Its conjugate acid is an alkane, so it's an extremely strong base. And when you finish with this chemistry, you've got an alkoxide, which is the conjugate base of an alcohol. So this is a much weaker base. This is favorable acid-base chemistry. And this is where it will stop after the first step. It has nowhere else to go. This is where step number 2 comes in, the acid source. Okay? Usually you use a dilute strong acid, something like sulfuric acid. It doesn't really matter though what the acid is as long as it's a dilute one. You can use HCl as well, or some other strong acid. But you will have some acid. When you have that acid present and you add it to this alkoxide, this oxygen will come in and remove a proton, give electrons back to the oxygen. And again, there would be some anion associated with this guy. I don't know what it is. Maybe it's a chloride. Maybe it's a hydrogen sulfate anion. Doesn't really matter. But once it has done so, you've protonated the oxygen and you've made an alcohol. And then you'd have your leftovers, the spectator ions. Oh, that was bad looking, sorry. Let me redraw. And if you'd used HCl, you would have had some water left over and maybe a chloride left over. It depends on what you used as your acid. But the point is, at the end of the day, those charges are all counterbalanced. Those are spectators that we don't care about. The important part is the alcohol you've made. You have been able to make a carbon-carbon bond. So that bond is being made, and that's very important because we like reactions that allow us to make carbon-carbon bonds. And you've also been able to make an alcohol. So two very important pieces that you're able to make from this particular type of a reaction.